Hello there. This is week 4 of our programming, where we talk about data manipulation and statistical analysis. Um, and I would say, in essence, we continue the work we already started in week 2, when we introduced how to import data into R, usually into a data frame, and we did some relatively basic already data manipulation. Now we just go a bit further into this topic. So learning outcomes, manipulate different data structures using appropriate functions, rectify incorrectly imported data. So we'll see a sort of case study of that. Summarize and organize data in a variety of ways, including with package dplyr. We'll explain in a second what we mean by a package. And then compute useful statistics. Bit of a refresher on data frames. So we would have seen already in week 2 that often we want to store our data sets in an object in R called a data frame. More specifically, it's a data structure, different, for example, than a matrix. So here we declare a basic data frame. Columns are those things. So there's a column for the name of somebody, their gender, their height, and so on. Now, maybe you can try to do this before I show the solution. What is the sum of everybody's heights? Well, that's relatively easy because you can access heights using, you see, if I call my data set y, then I'm going to access the height by y dollar height. So remember, this would be the vector that contains the height of everybody in the data frame, and then you get whatever this number is. Okay, the sum of all those numbers. What are the full details of James? So try to return the entire row that corresponds to James. And I suppose there's at least 2 ways to do this. Now, if you realize that James would be the second row because he's the second person, then you can just return the second row. And that would be a bit cheating because you use your knowledge that James is on the second row. More generally, you can use something like the following command, which is a bit more complex. You're going to grab the vector that contains all the names, and then you'll have the equality with James. But you see, this creates a vector of true, false, with true only if the name is James. But then if you grab the entire data frame and you take all the rows such that the name is James, and then you grab all the columns for that specific row, it's going to work. It's going to return, well, all the rows for which the name is called James. So in this case, there's only one. Now, maybe this is slightly confusing, so let me just do this in R directly, so to make sure we all follow. So I'm going to go to my R here. I'm going to create this data frame. Now we can display it here. It's called Y. Then you see it's as on the slides. And then let me just show you what this does, or remind you. So this, you see, will be a vector of true, false, because it's looking, okay, for all those names, so Y names, what are the ones that are equal to James? Well, this one is not, so it's a false. This one is true, and it's the only true. But you see, if you do the additional operation to grab the entire data set, this tells R, okay, I want the rows such that names equals James. Here, there's only one, but then comma, if I don't put anything here, it's going to grab all the columns. So then that's what we get. Rows that have name equal James, and then all the columns for those specific rows. Other example, what is the average income of the males? So again, conceptually, you would want to find all the males here. So the person number 2 and number 3, I suppose. But then for those specific people, you want to grab those incomes and take the average. So it gets slightly cumbersome, but you can do it in the following fashion. Again, the gender being equal to male will return true, false, depending on whether or not there's an M there. But then if you grab the incomes, then bracket, remember, this is going to be true, false. Well, you're going to grab exactly the incomes that have, the incomes of the people that are male. And then we can check that this works. And at the end, we just take the mean of that. So again, in R, this code will be 90 and 60 because again, the inner part will be a vector of true, false. Here it's false, true, true, false. Well, of course, because I first have false, that's female, but then I have true, that's male, that's true, that's male, and then female. And again, if I have the whole bit, well, I'm gonna grab the income, so the income column of my two males here. And the very last step is, of course, to take the mean of that, but that's pretty self-explanatory. Lastly, who is the shortest person? And they remind you that you can use which-min for that. Which-min gives you the position inside the vector of the smallest observation. So again, maybe it's easier to just grab the inner part of this code and see in R what this does. So which-min, so what is the position of the person with the smallest height? Well, you see, it's 4 because apparently Abby, the fourth person here, is indeed the shortest at 160. And then now I forget what the question was. The name of this person. Well, again, you grab the name of everybody, but then specifically you grab the fourth name because that would be indeed the name of the person with the smallest height. So some examples here of I suppose extracting data from a data frame. Now here, even if those are kind of basic examples, you might say that it's already a bit cumbersome, this syntax and this way to proceed. Here, they even use the word clunky in the slides. So if you think that, you're not alone. But there are some good news. In the last section of this week's slides, we learn about a more modern R syntax that makes manipulating data and doing those kind of simple operations, but even more complex operation, much simpler and kind of more tractable. So this will be the topic of this package dplyr. Now, what do we mean by a package? It's simply a sort of addition to what we call base R. So when you install R, you can use all the functions that are in so-called base R. And there's many functions, everything we've been covering so far. But then over the years, many people have created their own packages. So in a sense, additions to R that make your life easier when you use those packages to do specific tasks. And dplyr is part of a whole library of packages called the tidyverse. So dplyr is a specific package with specific functions inside it you can use. But then more broadly, there's a tidyverse that has other packages that do other things. But now here for this lecture, at the end, we'll cover dplyr, which specifically is going to help us to do this sort of data extraction, data summary, and so on. Okay, now this slide is maybe a bit of a side note about the attach function. So, well, let me read what's written there. If you use attach on some data frame, where here this is just the name of your data frame, it will create a workspace where each variable of the data frame, okay, this data frame, can be accessed directly without using the $sign. So you know, before, if we want to do something about height, well, we need to tell R, okay, it's height within the data frame called Y. So we need the syntax $. Okay, so within the data frame Y, we grab height. Using attach, if you use attach on a data frame, you don't need this. So you can directly access height in this example. So this then reduces the length of your codes. But here, I suppose the point is to be very careful with this. Frankly, if you search the internet, the standard advice really is don't use function attach. And I'll mention in a moment what's the problem with attach. My advice would be maybe a bit more moderate. I would say if you have a small project where maybe you're just using one data frame, then I think attach is fine. But once you start having a bigger project where in one R script you import many data sets, then I agree using attach is bad practice. And now here a bit of advice is given, like the attached columns, they really exist independently of your data frame. So if you make a change in the actual data frame, your attached columns, well, or objects, I should say, they will not change. And that is a bit tricky. Sometimes you might lose sight of this and make mistakes because of that. Um, now let me just make clear what we mean by attach, because maybe it's a bit unclear. If I have my data frame y, let me just show you in R, maybe it's going to be easier. You see here, y obviously exists, it's a data frame, but if I type gender, it's not going to work. Like gender as its own thing doesn't exist. I need to type y $gender to get the genders. But if I use attach on my data frame, which here is called just capital Y, then the objects in the environment will, actually they're not in the environment, interesting, but R knows that I want to be able to grab them, right? So if I type gender now, it should work. Yes, it should work. Now, again, the point is, if you update your data set, for example, here, Y gender, I'm erasing it, and for some reason I'm putting F everywhere. Okay, maybe there was some data mistake and I want to replace all the genders by F. Now, Y of gender is F everywhere, but gender, which is the one I had attached, has not been updated. And this can be a bit tricky if you don't know this or if you forget. Now, the other reason to be careful with attach is simply that very possible if you have many data frames, that some of them will have variables with the same names. In which case, it gets kind of confusing. You're going to attach one, but then you're going to attach another one, and you don't know what you're doing anymore, right? Imagine I have another data set that's not called Y, it's called something else that also has a variable called gender. If I've attached one of them or both of them, which is the correct gender? Well, I don't know, and you see this, can get confusing. But again, for small projects, if you have only one data frame, probably fine to use attach. And it does simplify your syntax a bit. Okay, now this was a bit of an aside. Now let me talk a bit about statistical analysis. And here we're going to use, for the next few slides, we use a data set called simply sample data. You can find it on ed, both on the ed resources and in the exercise space if you're using that. Now we will import the data into R. Again, I strongly advise you do this on your own computer in RStudio rather than ed, because again, in real life, you work out of RStudio. Now here, because we're just doing one task, I think it's fine. We're going to use attach, and this way we can access the variables directly. So here, this is just a syntax to import our data set. It's a CSV, so we can use read CSV. Header equals true, that's fine, although it's the default argument. So just typing this without header would do exactly the same thing. Again, attach means we can access all the variables here, maybe situations or tea or coffee and so on, directly without $. And head gives you a snapshot, the first 6 rows of this data set. And you see this is a data set about some people's diet, apparently. So you have their date of birth, their gender, their situation, but then all of this seems to be things about their diet, how much tea and coffee they drink. Okay, you have other more demographic variable, height and weight, age, but then how much meat they eat per week, how much fish, and other things like that. How much raw fruit, cooked fruit, okay, how much chocolate apparently, and fat. I don't really know, but it looks to be, I don't know, something about maybe it's the major source of fat in their diet, right? Sunflower oil, I suppose, or margarine is your for. I have no idea. But anyway, I suppose a few comments here. When you do statistical analysis, it's important to know what is the type of variables you have in your data set. And so here we have some variables that you would say they're purely qualitative. So gender, fat, situation, you see there's a few categories, male, female, single or not. And you see they're qualitative in the sense that there's no ordering and there's no, obviously those things are not numbers, but there's no ordering to them. This is in opposition to a variable that in statistics usually you call something like ordinal. Ordinal is a qualitative variable, so it's not numerical, but there's still an order to the different values this variable can take. So meat, fish, and so on, they are ordinal because indeed this is not purely a number. 4 to 6 times a week is not a number, but there's still a order to them, right? Um, you know, 4 to 6 times a week is more than 2 to 3 times a week, and 1 time per day is actually more than 4 to 6 times a week. And so you see, you can order those variables, which is conceptually different than something that's purely qualitative, like gender. Then you have discrete quantitative, so values that take specific 0, 1, 2, 3 values. But then you also have continuous quantitative, height, weight. Those variables live on a continuous spectrum. And then other, well, okay, date of birth doesn't really fit any of those categories. And we'll see in an example. Sometimes dates are a bit tricky to deal with. We'll see how to deal with a date type of variable in a moment. Here, there's a few more notes about how this data set was derived, but I think I'm gonna skip them. Okay, for numerical variables, quantitative variables, I should say, there's a few functions you can use, getting some basic information about your variables. So here we use weight. And remember, I can do that. I can use mean of weight because I've attached weight. In general, it again wouldn't work. But here I've attached, so mean of weight works, gives me the mean, the median. SD is for standard deviation. So the empirical or sample standard deviation of variable weight here. Sometimes you compute the difference between the max and the min. So, well, the spread between the largest and smallest observation. IQR is for interquartile range. So the difference between the 75th quantile and 25th quantile. Then here there's a bit more complex calculation. This would be the mean absolute difference. So the mean absolute difference, maybe we can explain the syntax. I take weight, which is a vector of numerical values. For every weight, I subtract the mean. So you see, this inside gives me every weight minus the average weight for everybody. But this can be a negative or a positive quantity. Obviously, if somebody has a weight below the average, well, weight minus mean will be negative. But here, ABS, it's absolute value. So I take the absolute value of every number here, the absolute value of every number here, and I take the mean of that. Now, I don't want to spend too much time on this, but this is essentially a measure of spread that is an alternative to standard deviation. Because you see, standard deviation here is a bit different. It takes, well, the average takes the average distance to the mean squared, and then the square root of that. But you see, mathematically, this is not equivalent to the mean absolute deviation. So basically, this is just an alternative way to measure the spread of a variable. And then you can get whatever quantiles you want. So quantiles, remember, it's the 10% quantile is the point at which 10% of observations are smaller or equal to that point. You see, so it's 51 here. 90% quantile is the point at which 90% of observations are smaller or equal to that point. And here, maybe just for the sake of it, let me verify that IQR should be the difference between the 75 and the 25% quantile. Let's check this in real time. Now I do need to load my data set here, so I'm going to copy this. In my R script. Hopefully that should work, unless, yeah, I probably don't have the right working directory. So I was not a good boy. I didn't set my working directory ahead of time. So let me do that. Set working directory to source file location. That should work because this file is where my data set is. So now it should work. Okay, very good. Then again, my point is that just to show you again, mean of weight. Should this work? Drum roll. Well, no, because I have not attached my sample data. So now I attach, and now this will work. And I just wanted to double check explicitly that quantile, we were using weight here, 75%, and then minus the 25%, this should be equal to the interquartile range. I believe that's what we got before. IQR. Indeed. So that's pretty good. And I believe that's it for those relatively simple statistics that might be useful for you if you're analyzing the variable weight. But now, maybe more useful is the function summary. So all of those things are nice, but those functions, you apply them to a specific variable. Summary gives you a sort of snapshot of, well, a summary of each variable in your data set, which is quite nice. Maybe in the first step, before you do more complicated data modeling, you want to have a summary of all your variables. So you use summary, and you see summary sample data gives me a summary of all the variables. For example, let's have a look first at the quantitative one. So it gives you the min, the first quartile, the median, the mean, and so on. So for age as well, you have a kind of a snapshot of the distribution of each of those variables. Now, for the other variables, date of birth, gender, it doesn't look to be very useful because you have length is, okay, that's just the number of data points for each variable. Well, it's always the same 226 because there's 226 rows in the data set. But then this is not very useful. It just tells me it's a character. And that's the case for all the variables that are not numerical. So that's kind of strange. And that's not really what we want. So here we face a very common issue that the data imported by R or in R doesn't have the format we want. Because all those things, we don't want them as characters. We want them as, well, different things. Either a factor or a factor with the order, or maybe a date, right? And those are the issues we're going to try to fix. And here, you might not have always these issues, but they're common enough that I think it's worth to spend a bit of time fixing those issues. And those are the kinds of issues you get with your, well, in your data analysis. So this is what I said. Gender doesn't have the right format. I don't want it to be a character. I want it to be a factor, as explained in week 2. Okay, a factor is the name in R for what we would call here in statistics a qualitative or ordinal variable. And also date. So the date of birth is a character. There's a format in R for dates, and which you should probably use, at least if you want to do something with the date. Okay, so let's review this. So here, for qualitative variables, those that take a few different categories, but without the order, you can just specify to R that those are categorical using the function factor. So you see, I'm going to erase the old gender variable and replace it by a variable that well, is also going to be called gender. So you see, this is the new gender, but I'm just calling the old gender and putting it into a factor. And that works. For the other ones, for the variables that are qualitative, but they have an order, it's just a bit more complicated. And here, I don't think there's like a simple solution. You need to tell R what are the categories and what is the specific order. What I mean is this. Okay, fish, again, is the amount of fish people have in their diet. Okay, as displayed over there. So, 2 or 3 times per week, 1 time per week. So you need to tell R, okay, this is a factor, but it's ordered, and you need to specifically give all the levels, all the possible values for this factor in the correct order. So basically here, you would need to check the data set, and okay, you find never, then the second smallest is less than 1 time per week, 1 time per week, 2, 3 times per week, and so on. Now, you don't have to guess those. You can just look at the data with this command. We can maybe try unique, and whatever you put inside unique will give you all the values. Okay, which here, because I attach my data set, unique fish should also work. Yeah. Well, obviously you can type just fish, but fish will just give you all the values for fish for all the people in the data set, right? So unique just gives you the unique ones. Okay, here, well, there's a note. The other variables have been corrected. So in the background, we correct them. We haven't put all the details there. I suppose it's an exercise for you to try to correct meat and whatever all the other qualitative variables are. But then we're going to show you the final result. Okay, final result in a second. So this is how you would code correctly and tell R, okay, this is not a character. It's not a character. It's a factor. Now there's the other issue of dates. So um, again, the problem is that in the imported data set, maybe I can show you in R, date of birth here is a character. Now this could be fine. It depends on what you want to do with date. But if you want to do something with date, you probably wanted to have it in the date format, and this is where the R function as date comes in. Now, dealing with dates, honestly, can be a bit annoying because, of course, dates can be stored in all sorts of format, right? The year first or not, and then is the year abbreviated or not, and so on. So you need to convert a date that is here a character, to convert it to a proper date. You use as date here, but you need to specify what is the format, like the actual display in your data frame. So here you see the way DOB is year as four numbers, and then 01 for the month, and then the day. So you need to tell R this, and here that's the syntax to use. Frankly, I usually don't remember it, and I Google it, but here, $ capital Y actually means that the date has 4 digits. And then $ month would tell R that, okay, there's the month after 2 digits, and then there's the day 2 digits. And this is enough to tell R, okay, my date is now going to be stored in the proper date format. And of course, there's many different date formats that you can review, for example, at this link. If you have a date that is only 67, for example, like 2 digits, well, you would need to use a lowercase y. Frankly, I don't think it's relevant here that I present all those cases because anyway, I myself don't know them by memory. I need to check a link like that whenever I need to deal with dates. And here, just a note, maybe it's not so obvious why we spend some time on this. Why do we want the proper date format? Well, if you want to do a visualization where you visualize something by date, you would need to have it as a date format. Otherwise, it's not going to work because dates that are characters, they don't have an order to them. But dates that are in the proper format, they have an order to them. Now, just to give you a small use case, if a date has been stored using as date, you can manipulate it with like addition and subtraction, right? So what I mean is simply this. Here, this is a function in R to get the date of today actually. So today, at least at the time of recording this video, is 21st of June. So here, system date creates a date in the proper format. Okay, it looks like a character, but it's actually a date. So then I can do manipulation like add 7, right? So if I add 7 to today, it adds 7 days, which is probably the behavior I expect, right? Today plus 7, then I get the date in obviously 7 days. But if I just type this in R, this thing here typed like that in R will be a character, not a date. And if I add 7 to it, I'm going to get an error message. That doesn't work. So I need to have it as a proper date format to do things like that. Okay, and one last note. R stores dates, I suppose, like internally, always in the same format. Okay, so always in the format, 4 digits for the year, then month, then day. Okay, so year, month, day. That's all R as dates inside it, I suppose. Now, if you don't like this, you can actually display the date to the format you like using a function called format. Careful here, format is a function in itself. Don't confuse it with what was here an argument format of the function as date. But anyway, you can display it in the format you want, but when you do that, it's no longer a date it's no longer a date in terms of like a data structure. So just an example of this. Okay, today plus 1, remember today was this thing here that is a proper date, that's fine. So today plus 1, I can obtain the date of tomorrow, right? But now if I don't like that it's displayed like that, year, month, year, month, day, for some reason, I want day, month, year. That's fine. I can use format and then tell R, okay, I want day, month, year. But maybe annoyingly, when I do that, the result will no longer be a proper date. It's going to be a character. Okay. That's the behavior. I'm not in charge of this, so maybe that's a bit annoying, but it is what it is. I can create tomorrow and then it displays like I want. Okay, 20, day, month, year. But then if I take tomorrow plus one, it doesn't work because again, using format, I've changed it back to a character. Okay, I don't know if those details are useful, but I suppose this is just a bit of an explanation that dates sometimes can be a bit annoying to deal with. You kind of need to, I suppose, Google it or ChatGPT it to figure out whenever you have a problem with your dates. But anyway, now that we fixed our variables, the qualitatives are now proper factors in R, and the dates are proper dates. Then when I call my function summary, the information I get is much more useful. Because you see, date of birth, actually, because it's dealt internally, I suppose, as something that has an order or even a numeric, um, I can get the minimum, right? The smallest date, I can then get the maximum, the biggest date. I can even get the mean. Okay, what's the average day in this data set where, you know, days that are far apart by one day, well, it counts as like, it's like a numeric, right? They're apart by one, a unit of one. And then for gender, then I get useful information. Okay, I know that in this data set there's 141 female, 85 male, and so on. Situation, okay, couples, family. For some reason, very few families in this data set, which maybe is sad, but it is what it is. And also for my ordinal variables, you see I have them in the right order. So I see, okay, only one person never eats meat. Okay, not many vegetarians in this data set, and then less than once a week, only three, and you see, okay, the people in this data set are big meat eaters for some reason, um, and so on. So this again, I've kind of fixed my problem that now I can see properly, quickly, lots of useful information about this data set. Okay, just a few comments. A good data analyst always checks the format and quality of the data they imported, of course. Before you start doing more heavy analysis, you need to make sure you have the correct formats. Now, the previous slides have shown a few simple cases. There are many more potential issues that you can and will encounter when importing data. Unfortunately, maybe there's just no escaping it. Maybe this is all a bit boring, but cleaning up these kinds of issues is often a large part of your work as a data analyst. A few more functions. So frankly, table gives you information that's a bit redundant with summary because table of situation, which here is a factor variable, will give you same information we had before. Like there's a 119 couple, 9 family, 98 single. Okay, so it's exactly the same information as was here. However, maybe it's a bit more useful that you can then use table on 2 variables and get a table in 2 dimensions. Here, by the way, this is not, well, this is just getting the percentages, right? So if you grab your table that here is called TC and you divide it by length, well, length of situation is just the number of people in this data set. So if you divide those numbers by length, you get proportions, right? 52 and a bit are couple, only 4% are family, and so on. But what I was saying before is you can use table on 2 variables, 2 qualitative variables, so gender and situation, which creates a table like that can be quite useful because then okay, for couples, well, I should say for people that are female, well, sorry, how many people are both female and in a couple? Okay, how many people in this data set are both female in a couple? Well, 56. How many people are female in the category family? 7, and so on. So you see, you combine 2 categories together. Okay, and this thing is simply adding margins. Yeah, it can be useful to know the sum of the rows and the sum of the columns, which honestly, there's many ways to do this, but there's actually a function called add margins where you can add, okay, in total, how many females in total? Well, 141. How many males in total? 85. And so on. And the same, how many couples in total? 119, 9, and 98. Which again, I suppose we already had this information. 141 and 85 should be what we had over there. Yes, indeed. Okay, then another very useful statistical tool is the correlation. So this is something we'll cover in the theory part of the course, like what exactly we mean by correlation in terms of a mathematical definition. But here, for the sake of just presenting the command in R, we're not going to explain too much of the theory, but just quickly, the correlation between two variables measures their linear association. So when you plot those variables, here underlying assumption is that those are numerical variable. When you plot them one against the other, do you get a straight line or not really? So if you do get close to a straight line when you plot one variable against the other, then the correlation should be high. If it's a large number, I should say, if it's a positive number that is close to 1, then the correlation is high and positive. If it's a number close to -1, well, the correlation is also high, but it's negative. Now, just as an example, you can compute the correlation between, here there's a data set called empty cars. So sorry, the correlation between the weight of a car, so weight of the car apparently in thousands of pounds, and their miles per gallon. So, well, in terms of, distance, how much distance they can cover per gallon. So you see the correlation, and in R, you simply use the function core. So the correlation between weight and MPG is negative and quite strong because it's close to -1. Theoretically, the correlation can only be between -1 and 1. It's technically impossible for the correlation to be outside those bounds. So if it's close to -1, it means you have a strong negative association between weight and miles per gallon, which makes a lot of sense. Like, well, if a car is heavy, well, the car will be able to do fewer miles per gallon because it burns more fuel, of course. Now, just to give us a slightly better understanding of this data set, if you actually plot miles per gallon as a function of weight, you get this, and indeed you see the relationship looks quite strong, and it's a decreasing one. The heavier the car, the less miles per gallon they can do. Okay, and of course here, this is just one plot. Next week we say much more about visualization and creating such plots. Well, here it's very simple syntax. You use a function plot. This is the first arguments, whatever you want in your x-axis, whatever you want in your y-axis, and everything else is more graphical display, like the title, the labels, and so on. Here it's a bit boring. We could have put colors there. We'll do that next week. A bit of an exercise for you, very similar to what we just discussed about correlation. Use the dataset cars. So careful, I believe this is a different dataset. It's called cars. And by the way, here, some datasets are in base R, right? You don't need to download them externally. They're already in R. Maybe I can just show you that this is indeed in R. So what is this one called again? Empty cars. So if I go to my R Studio and I type empty cars, this dataset is already there, right? I don't need to import it from elsewhere. It's already there. There's another one called just cars. Okay, that has only 2 variables here, speed and distance. Now your job in this exercise is find the correlation between speed and distance, and then maybe see if you can find some interesting findings there. It's an exercise, very straightforward, so I think I'll let you review it and check the solution if you want. The next section is about dplyr. I do want to make a separate video for dplyr, so I'll stop here. I'll thank you very much for your attention, and again, I'll catch you in the next video, which will be dedicated to this very useful package, dplyr. But I stop here, and I'll see you soon.